A truck chassis with a wheelbase longer than an entire 1967 Chevrolet Impala. This is not a simple visual modification. It is the physical answer to a critical question. Why stretch the frame? The reasons diverge down two opposing roads. One is born from cold logic and regulation, a matter of work necessity. The other is pure passion, an expression of style. One path is dictated by the precise, unforgiving language of law. The other is defined by the builder's vision to create something unique on the highway. This exploration of extreme engineering will conclude with a vehicle that more closely resembles a highway train than a conventional truck. The analysis begins with the laws that force steel to bend. The answer lies not in style, but in regulation. The critical driver was a set of restrictive highway laws from the 1970s that limited the overall length of a truck and its trailer. To maximize payload, engineers faced a brutal equation. Every inch saved on the tractor was an inch gained for the cargo. This is the result. The 1992 Kenworth K100, a machine born from necessity. The cabover design placed the driver directly over the engine, radically shortening the front end. This allowed the wheelbase itself to stretch to an immense 240 inches. On screen, a graphic traces the frame. Over 5 meters of steel. A standard tractor of the era measured between 200 and 220 inches. This was a dimensional leap of nearly 20%. Underneath the cab sits a Cummins 14-liter inline-six diesel engine, a power plant known for raw durability, producing around 400 horsepower. That force was channeled through a 13 or 15-speed Eaton-Fuller manual transmission. Operating it was a purely mechanical process. Each shift was a deliberate physical action, a heavy click echoing through the cabin, demanding precise timing from the driver to manage the engine's power. There was no room for error. The distinctive flat-nose profile became an icon, popularized by television shows like BJ and the Bear, but that fame was a byproduct. The design itself was a cold, pragmatic solution to a legal and economic problem. This truck's form wasn't shaped by an artist's desire for a long silhouette. It was dictated by the need to fit the longest possible trailer within the 65-foot federal length limit. And the Kenworth K100 was not alone in this engineering race. Competitors from Freightliner deployed the exact same cabover philosophy, pushing the design to its logical conclusion under identical regulatory pressure. This was the 1989 Freightliner, a workhorse built for the highway, not the showroom. Under the cab, the standard power plant was a legend of durability. The Detroit diesel 12-liter engine. It delivered over 400 horsepower, channeled through a 13 or 15-speed manual transmission. This was a purely mechanical drivetrain, a system trusted by fleets for its reliability across millions of miles. But the defining characteristic was the frame itself, 255 inches. The wheelbase measured nearly 6.5 meters. This wasn't an aesthetic choice for a more elegant silhouette. It was a calculated response to a legal formula. The longer chassis was a direct enabler for hauling the longest, most profitable trailers possible within the overall length limits. By the late 1980s, this long wheelbase cabover design was not an exception. It was the dominant species on the road. But what happened when the regulatory crisis ended? The laws changed. Overall length restrictions were lifted, and the need for the compact, space-saving cabover design vanished. A completely different philosophy entered the scene, embodied by a machine like this, a year 2000 Kenworth W900L. Here, the long hood is not a compromise. It is a declaration of freedom. This is the new canvas for the American trucker, and this specific build from the Texas Chrome Shop is an exercise in excess. Underneath the polished facade is a 15-liter Caterpillar engine, an inline-six workhorse tuned to produce around 550 horsepower, all controlled through the tactile feedback of an 18-speed manual transmission. But the engine is just the starting point. The entire frame was stretched to a wheelbase of 250 inches, 6.5 meters. That is the length of two classic Chevrolet Impalas parked bumper to bumper, with space still left over. This space isn't for a longer trailer, it's for a statement. The customization is absolute. The truck stands on its polished frame, a mix of mirror-finished chrome and deep powder-coated components. A close-up on the engine reveals intricate engravings etched directly into the housing of the turbocharger, a detail far beyond mere function. Inside, the driver is surrounded by multiple digital screens, while their feet rest on custom-milled aluminum pedals. Then, the hiss of compressed air releases. The multi-ton machine settles low to the ground, shifting from a road-ready stance to a show floor posture. Functionality was no longer the primary objective. With the removal of overall length restrictions, the market's focus shifted from utility to status. But what became of the symbol of the old era, the cab-over truck? Some, like this 1984 Peterbilt 362, attempted to find their place in this new world. Their strategy was simple: stretch the frame. The result is a technical paradox. A flat-nosed cab, engineered for maximum cargo within a compact footprint, now sits on a chassis stretched to a wheelbase of 276 inches, 7 meters, the length of two business-class sedans parked end-to-end. This is a design fighting its own DNA. On the surface, it's an attempt to mask this conflict. Deep purple and stark white paint plays across its panels, a glossy wrapper over a utilitarian core, but the truck's fundamental mechanics are unchangeable. The entire cab tilts forward on its hinges. A hydraulic system lifts the living space away from the chassis. Revealed below is the engine, the true heart of the machine. Bolted directly to the elongated frame is a Detroit Diesel Series 60, a 12.7-liter inline-six, the workhorse of a generation, now framed by custom paint and chrome. It is engineering from an era of pure function. This was a machine built to work, now dressed for a show, an attempt to make an obsolete architecture relevant again. But for a cab-over, 276 inches was the technical limit. The cab-over's architecture had reached its limit. For the conventional long hood Kenworth, that limit was merely a new starting point. Customizers had a new canvas. The frame was stretched from 276 inches to 315. 8 meters of steel now separated the axles. This aesthetic choice immediately created an engineering problem. More steel means more mass. This is the technical price of style. That additional weight requires compensation. The first payment is made at the engine block. The solution is a proven 14-liter Cummins inline-six, pushing over 450 horsepower. This isn't an option, it's a necessity to move the newly burdened chassis. To manage that power and the inertia of the extended frame, the engine is paired with an 18-speed manual transmission, a chain reaction of force. Stretching the frame was only the start. The next step is to add something onto it to hide its true scale. If the 315-inch Kenworth was a statement, this blue Peterbilt is an engineering paradox. From a distance, it appears proportional, a classic long hood design, but a change in perspective reveals the deception. A hard cut to the side profile. The true scale is shocking, 325 inches. The wheelbase is longer than a standard city bus. It is an exercise in excess, a chassis stretched to its visual and physical limits. To move this mass requires the proven power of a 14-liter Cummins engine, delivering over 450 horsepower through an 18-speed transmission. But the power is not the story here. The story is a visual lie. The question is, how do you hide this extreme length? You add complexity. A third drive axle is installed, creating a dense, visually heavy group of 6 wheels beneath a massive sleeper cab. The sound is a low, throbbing hum from 6 tires gripping the asphalt, the sound of immense traction and redundant mass. These elements combine to create an optical illusion, tricking the eye into perceiving a more compact form. An engineering solution to a problem created by aesthetics. Why add a complex and heavy third axle? To conceal what you yourself have built. It is an act of visual correction. The third axle is a solution for mass and for visual balance. But what if the goal is not to hide the length, but to emphasize it, backed by pure power? While adding an axle solves the problem of mass, this Peterbilt 379 answers a different question. How to move a 350-inch chassis not just adequately, but with absolute authority. The owner's choice was not about utility, it was about a statement. The hood lifts, revealing the engine bay. The power plant at its center is an icon of heavy industry. The Caterpillar C16, 15.8 liters of displacement, 600 horsepower. This engine isn't here to merely haul a load, it's here to move the chassis itself with an overwhelming display of force, managed through an 18-speed manual transmission. The statement of power is matched by a visual one. The paint is a custom candy green. This isn't a simple color, it's a structure. Layers of tinted lacquer over a metallic base create a surface that seems liquid, a depth that pulls the eye inward. It is the visual equivalent of the power coiled beneath the hood. The wheelbase stretches to an extreme 350 inches, nearly 9 meters. On a parking lot, it requires 2 standard car spaces, measured lengthwise. This machine is the apex of a philosophy. It combines the maximum chassis length of its class with a power plant designed for pure dominance, an act of engineering self-expression. Projects like this demonstrate a growth in complexity, but the true physical limits of chassis length were reached in machines where the wheelbase is measured in hundreds of inches. The true crisis of practicality begins when a truck's wheelbase, like on this Peterbilt 362, reaches 330 inches. This is not an upgrade, it is a fundamental engineering compromise, turning a work tool into a static exhibit. The space between the front and rear axles measures 8.3 meters. A graphic shows a line connecting the wheels. The length of the frame rails exceeds that of 2 business-class sedans parked bumper to bumper. This scale creates a profound visual dissonance. The cab-over engine unit appears unnaturally detached from its drive axles, as if 2 separate vehicles were joined together by mistake. An engineering liability. Power comes from a standard 14-liter Cummins engine, a reliable workhorse, but its power is now secondary to the problems created by the chassis. The primary issue is maneuverability. An animation shows the truck attempting a turn, its turning radius absurdly wide compared to a standard rig. It cannot navigate a city street corner. It struggles in a loading dock. Then there's the issue of structural integrity. A frame this long is subject to immense torsional flex under load. Every bump in the road, every slight turn introduces twisting forces that the original design was never meant to handle. The frame twists. The visual effect is achieved. But at what cost to maneuverability and structural integrity? If the 8.3 meter wheelbase on the Peterbilt 362 already compromises its function, this Kenworth K100 project escalates the engineering trade-off. The distance between its axles stretches to 380 inches, 9.6 meters. The powertrain, a standard Cummins diesel and a multi-speed manual transmission, is a technical footnote made irrelevant by the sheer audacity of the chassis. Here, the aesthetic attempts to justify the scale. A deep, glossy brown enamel is paired with massive, mirror-polished fuel tanks that run the length of the frame. They are not just for fuel, they are visual tools designed to make the impossible length look intentional, even elegant. But this elegance is a mask. The Kenworth K100 cab-over platform was chosen for a reason. Its original design was compact and efficient. Stretching it to this extreme negates its core engineering purpose. The aesthetic has completely defeated the function. The form is a declaration. The function is a compromise. 9.6 meters between the axles. But even this figure is not the limit. The escalation of length in cab-over designs reached a physical limit at 380 inches. To push further, a fundamental shift was required, a new platform. This led to the absolute record holder, a Peterbilt 359 given a personal name, Johnny Holmes. It stretched the wheelbase to 420 inches, 10.5 meters between the axles, a length equivalent to a standard city bus. At this scale, the standard Peterbilt frame is no longer viable. A factory C-channel frame is designed to flex, but only within engineered limits. Stretching it to over 10 meters introduces massive bending forces at the center, creating critical stress points that threaten to buckle the steel. Imagine the constant torsional stress on metal beams the length of a telephone pole, fighting to twist and deform with every mile. The solution was not mere customization, it was a complete re-engineering of the structure. Additional cross members were welded in to prevent twisting. Reinforcing plates, known as fish plates, were bolted along the primary rails, multiplying their vertical rigidity. This level of modification moves the project Johnny Holmes out of the realm of simple stretching. It is no longer just a truck. It is a purpose-built structure designed to solve a single problem: how to support its own extreme length. The result is an engineering artifact. Its only real function is to dominate on the show field. The Johnny Holmes project, with its 420-inch wheelbase, is the logical apex of the trend. But it forces a central question: where is the line between the art of customization and engineering absurdity? This entire phenomenon is a study in escalation. It begins with a desire for distinction and ends with a vehicle transformed. The wheelbase range expands from 300 to over 400 inches. At this scale, a fundamental engineering compromise is made. The vehicle's structural integrity is pushed to its absolute limit, battling immense torsional stress on every uneven surface. The laws of physics are absolute. The result is a new classification of machine, the show truck. Its primary function is no longer transportation, it is demonstration. The ability to haul freight is sacrificed for the single purpose of visual dominance, creating an engineering artifact that cannot perform its original task. So what is this? The pinnacle of engineering audacity, or a costly dead-end branch in the evolution of the work truck?